DKTE Society's Textile and Engineering Institute, Ichalakaranji, Kolhapur, the largest textile and engineering institute in Asia and the one most trusted amongst engineering aspirants and even the industries worldwide.
You can be observe the SCR characteristics, VI characteristics of the SCR. SCR is the silicon control rectifier, is one of the industrial conducting device, industrial conducting devices. SCR is this, here you can be used TYN612 SCR, and that for this you can be used this input supply AC. That SCR is the rectifier, this is the control rectifier which is used on that is the as well as the AC to the DC or DC to the DC, all in 4 quadrant of this conversion mode, that is this AC to DC, DC to DC and DC to AC. All these rectifiers and the converters you can be used the SCR as this controlling element, controlling the device. SCR is the power controlling the device, mostly used in the industrial purpose. And here you can be used 230 volt to 110 volt AC supply, 230 volt, that is the to the 110 volt AC supply to the isolation transformer, and then this isolation transformer to AC 110 volt used to this equal VAK supply of this SCR TYN612, and that is from first element is the 100 ohm current limiting resistance, and then you can be go to this phi anode of this SCR and to this cathode of the SCR connect to this input pin of that is the transformer, and this is R2 and the R3. These are the used for that is the measurement of the VAK voltage on this CRO, measurement of the VAK voltage, that is the VAK voltage on the CRO X channel, and then you can be observe the gate current, that is the through the load lamp. This is the load through the in this series with the SCR. You can be use the 2 load, this is SCR1 load and this is the SCR2 load. You can be one load is short across this short circuited by the wire, and then other load that you can be used the 200 watt burst lamp load. This is the acting as the lamp load, and then the gate terminal, that is the VGK voltage applied from that is the 0 to 5 volt supply as the DC supply, that is the you can be used 2.5 that you can be vary this one, and as you can be vary that is the your forward breaker voltage is varied, and this is the forward breaker voltage you can be varied, and that is the launching current is also the varied and goes into the conduction state of this SCR. Here you can be these experimental setup of the SCR characteristics. You can be observed that is the input voltage 110 volt, that is R2 R3 measuring elements, and that is the lamp load, and that is the R1, this is the current limiting resistance, and that is the VG, this is supply, and the RG, that is the gate resistance, and that is the TYN612, that is the 12 ampere Thyristor. This is the Thyristor N natural commutation. Natural commutation means that is the natural point of that is the zero crossover point of the AC supply. This goes into the commutate. This Thyristor is the commutate at the natural 50-60 Hz input supply. Commutate. There is the no necessary of the DC commutation circuit. This is turning off circuit of this TYN612. Then you can be first you can be start this experiment, and you can be vary this gate supply. Thus you can be vary the gate supply. You can be change this breaker voltage. That is the breaker voltage. You can be observe measurement of this breaker voltage. You can be set this dot at the center of this shadow, central skin of this shadow, and then you can be remove this ground, and such this is the V breaker voltage. This is the conduction state of this. This is the forward breaker voltage up to this point. At this point SCR goes into the conduction, and then here the latch and goes into the power conduction mode. It goes into this power conduction mode of this SCR. You can be observe these characteristics. This is the actual, this is the I on this y-axis, current is the current on the y-axis, and the on the voltage on x-axis. This is the voltage on the x-axis. Here this is the forward conduction mode, and this is the reverse conduction mode. This is the reverse conduction mode, and this is the forward conduction mode. In this forward conduction mode, this is this up to the forward black hole point. At this black hole point, SCR goes into the conduction, and then SCR goes into the forward conduction state. At the linearly, voltage and current are this increase. This is the forward conduction mode. Once it get triggered, by the VG. When it get triggered by the particular VG at the black hole voltage, then it goes into this conduction state. That is the linearly phi and the I linearly proportional depending on that is the load of this SCR. Depending on the load of the SCR. This is the SCR characteristics, and this is the reverse characteristics of this SCR. That is the as like the diode of this SCR diode, as like the diode, and this is the power conduction mode in the A time. Then you can be measurement of this take place the measurement. Here you can be apply, that is the 110 volt phi AC voltage, and load resistance is the 100 ohm, and then that is the you can be measure the forward breaker voltage. Here forward breaker voltage, this one 1 2 3 1.6. Now take the measurement on this shallow. Here this is the phi breaker voltage 1.6 into 0.5 into 10, that is the attenuation factor of this probe, that is the 8 volt, and 8 volt upon the load resistance 100 ohm is equal to 80 milliampere. 80 milliampere is the approximately equal to the 60 milliampere of the Ig of that is this gate current of SCR TYN61 series, TYN61 series 612 series. This is the Ig, that is the Ig is equal to phi forward breaker voltage upon RL, that is this forward breaker voltage upon the RL, that is the 100 ohm load resistance. This is the Ig, and then you can be observed, and that Ig you can be varied with help of your that Ig you can be vary the forward breaker voltage also the vary. See, you can be like this one, vary this Ig, vary the forward breaker voltage, and then corresponding the IH. Then you can be observe the SCR voltage and current waves. This is the load current. This is the load current of this SCR. Load current. This load current, that is this on the Y. This is Y channel. This alpha plus beta. Alpha pi. This is the negative half cycle plus alpha. Negative half cycle. This negative half cycle plus alpha is equal to this is this conducting off state of the SCR, and beta only conduction state SCR is goes on, and this conduction angle can be changed with help of your gate voltage. See, like this you can be change this conduction with help of this conduction angle, and this is the some part of the positive cycle controlled by the SCR. Negative cycle is drop across the SCR, and from some part of the positive cycle is also drop across the SCR, that is this alpha, this is some part of the positive cycle, and the pi, that is this non-conduction state of the SCR, and the beta, that is the only conduction state of the SCR. Only conduction state of this SCR. This is the alpha plus beta is equal to 180 degree, 360 degrees, 180 degree negative half cycle, 180 degrees positive half cycle, and positive half cycle include alpha plus beta, that is alpha filing angle and beta conduction angle. You can be measure this alpha and beta on the shallow. You can be also measure the alpha plus beta on the shallow. Then you can be this is the, and then you can be observe the voltage. Then you can be observe the voltage, the negative half cycle as well as the some part of the positive, that is this. This is a voltage phi SCR of this phi SCR. This all the voltage stable. This is negative cycle, and as well as the alpha plus negative, cycle is the phi SCR, and this is the load voltage, this is beta. This is phi SCR of phi SCR, the voltage VA ke voltage of this SCR across the SCR, and this is this the current through the SCR current, and this is the voltage. You can observe this one. This is the for this particular state of the Vg here. This is the alpha conduction state, conduction of the SCR. Here it takes place, and this is a beta, and here this is the non-conduction, which takes place from the zero crossover point, negative cycle, and this is alpha. Alpha plus negative cycle half pi is the non-conduction state of this SCR, and this is the conduction state of this SCR. This is the beta. Beta is the conduction state of the SCR. Thus, you can be complete the positive as well as the negative half cycle of the input. Positive as well as the negative half cycle of the negative. This is negative and this is a positive cycle. This is the from these two crossover 360 degrees is completed. Out of 360 degrees, 180 plus alpha is the non-conduction state of the SCR, and beta is the conduction state of the SCR. Then you can be change these Vg. Also, you can this is the you can be change this your conduction angle. This is the off state of this SCR, and this is the on state, fully on state of the SCR, and that is the fully on state of the SCR. You can be observe this one. This characteristics like as the diode. This is the acting as the uncontrolled rectifier, acting as a diode. SCR is the acting as diode uncontrolled rectifier, as the alpha is equal to 0 angle, beta is equal to 180 degrees conduction angle. And whenever you can be conduction alpha is takes place, then this is the breaker voltage, this is the alpha is the takes place, alpha and the beta. This is the power breaker voltage takes place. This is the phi of BO, and this is the SCR conduction power conduction state. This is SCR. The phi SCR alpha plus negative beta and phi load beta. That is the input cycle of the supply. 180 negative cycle, 180 positive cycle is equal to 360 degrees. And phi load, this is this. You can observe this one. This is the phi load voltage, and this is the phi SCR. Phi load is acting as the phi current. This is the load current, and this is the load voltage. And that load current and voltage you can be observe. These are the characteristics on this SCR.